Let's do math. All right, so let's try again. So section, section 7.2. So we're going to do the addition and subtraction formula. So here, if I have sine plus or sine of s plus t, this is sine of s plus cosine of t, or sine of s plus sine of s times cosine of t plus cosine of s sine of t. And then if I minus it out, I'll just do a minus. One way of writing this, you could just write, another way of writing this would be sine of s plus or minus t equals sine of s cosine of t plus or minus cosine s sine of t. And then here if it's plus, it's minus, and if it's minus, it's plus. Another way of writing this one, just so you guys see it at least once, is minus plus. I don't know if you've ever seen this symbol. Let me write this as plus minus t. Hold on. And this equals cosine of s, cosine of t minus plus sine of s, sine of t. And so I don't know if you've ever seen this symbol, and you only see the symbol after you've seen the symbol. So this plus minus, if you see minus plus, it means if you took the plus here, take the negative here. If you took the negative here, take the positive here. That's all that symbol's mean. And so you can rewrite all these into this. And so here, what would we actually use this for? So, so here I want to find the exact values without using the calculators. So back in the day before we had calculators everywhere, if I want to know what this is exactly, how to calculate that out, well, here I have cosine of 75. Well, cosine of 75 is, well, 70, do I know two numbers? Do I know cosine of two numbers that add up to 75? Do I know two, can you think of two numbers that we know that add up to 75? Yeah, so 37.5, and that would add up to 75, but 30 and 45, we actually know what those are. So here I have 30. So I can rewrite this as cosine of 30 plus cosine of 45 degrees, and then the next one we're going to do in pi. That way we get used to both. So here, according to this, I can use this formula right here. So I'll have cosine of 30 degrees plus, or no, multiplied by cosine of 45 degrees plus sine, oops, hold on, if this was plus, that's negative, right? This is plus, this is now negative. Sine of 30 degrees cosine of 30 degrees. Nope, nope. I've lost my mind. Sine of 45 degrees, sorry. All right, and what are the values here? I'll just give them to you. You should have them memorized, but if not, I'll tell you what they are. This is square root 3 over 2. This is going to be square root 2 over, it does not look like a 2, 2 over 2, minus, this gives me a half, and this gives me square root 2 over 2. So notice here on the bottom I have 4. Here on the bottom I have 4. Here I can multiply these together, so I'll get square root 6 minus the square root of 2. Multiply these together, all over 4. And that's the exact answer. And so here I've used these to produce this answer. For this one, here I want to get pi over 12. Do I know how to get pi over 12? Well, here if I took pi over 4 minus pi over 6, that equals pi over 12. Because if I brought both of these to 12, this would be 3 pi over 12 minus 2 pi over 12 gives me 1 pi over 12. And so here I can do this again. So here we're going to do cosine of this. Now we're going to do the opposite. So it's going to be cosine of pi over 4, cosine of pi over 6. So this would be minus, so this now becomes a plus. For cosine, we switch it, right? So here, if I had minus, it now becomes a plus. Right here. Sine of pi over 4, still sine, sine of pi over 6, and then I just plug in the values for this. So this is square root square root of 2 over 2. This is square root of 3 over 2 plus square root of 2 over 2, 1 over square root of 2. And so here I get the square root of 6 plus the square root of 2 all over 4. And that's the exact answer. All right. And so we also can do this backwards. We also can do this backwards. So let's go ahead and do that. So let's go ahead and do this backwards. So if I wanted to find the back value of this expression, so here I have this. Well, this is, if we look at our little formula sheet, let's go up to our formula sheet. Here I have, what do I have? I have sine times a cosine plus a cotime times sine. If I look here, do I have anything that looks like that? Oh, here I have sine plus a cosine plus cosine plus sine. And if we looked at them together, we would notice that this would match. And so this is really just sine of 20 degrees plus 40 degrees. So you can go the other way, which is equal to the sine of 60 degrees. And do I know what the sine of 60 degrees is? Yeah, that's square root 3 over 2. Now, if you chunk each one of these through the calculator and add it up, you're going to get the same value. But here we don't need to. All right. And so let's do kind of a proof of an identity. So we're going to prove this identity. So I'm going to prove the cofunction identity. So here, how are we going to prove this? Well, we're just going to use our double angle, our add addition subtraction formula here. So cosine of pi over 2 minus that would be cosine of pi over 2 times cosine of x plus sine of pi over 2 plus or times sine of x, right? That's just literally what this is. And okay, so what's cosine of pi over 2? Does anyone remember? What's this? 0. Yeah, so this is 0. And so I'm just left sine of pi over 2 is 1. So this is just equal to sine of x. So here we've proven our cofunction identities, and this is an official proof, right, that this works if we assume that the other one is true, that this equals sine of x. So that's just something fun to do. All right, so let's use this to verify more identities. Yay! Look at this awful beast, right? So let's do this. So here we can mess with this, but let's just start with the right-hand side, right? Let's just start with the right-hand side. Right-hand side. So we're going to start here. So this is just one of my happy formulas. And so here it's this formula right here. And so I'm going to just write down what that is. And so here my s in this case will be this, and this will be my t. So this tangent becomes tangent of pi over 4 plus tangent of u. Notice that matches here. Tangent of 1 plus the tangent of the other, then 1 minus the tangent of them multiplied by each other. So let's do that. 1 minus tangent of pi over 4 tangent of u. Well, what's tangent of pi over 4? For the formula of cosine, what is this? Oh, let's go back. For the formula of cosine, what is in the circle with the arrow pointing to it? Oh, this is the symbol. Let me write it real big. This is the minus plus symbol. So if I have a plus minus symbol, and then I see this minus plus symbol, it means to take the opposite. So here, if I rewrote this as minus plus and then plus minus, right? So here, it'd be cosine of s plus t equals to cosine of cosine s cosine t minus, because if I took plus, I'll take the minus here, sine of s sine of t, which is as is written in the text. And then if I did cosine of s minus t, it'd be cosine of s cosine of t, or cosine of s times cosine of t plus, as you see the one down below. So this is just a way of saying, it's just a symbol that you may or may not see. Oh, it looks like an X. Yeah. No, when I circled it, I made an X. Sorry about that. But I want you to, I see how I can say this properly. When you leave this class, if you, the capability to do all the math problems I give to you is not and is not as important to me as the ability to think mathematically or to read mathematically. And I think that's going to be more beneficial than be able to solve these trig identities, right? The goal of all of this, the real goal for me when I send you the calculus is, yeah, are you going to use some of the stuff in calculus? Of course, right? Are you going to use all of it? No, right? The goal is to get you used to thinking mathematically and to think mathematically and to be able to operate mathematically, to read mathematical language and understand what it's saying, and then to think mathematically. What do I need to do here? And try to sort it out. So that's the real goal. So here I have this, and so I do this, and so tangent of pi over 4 is, of course, 1, right? And so since I know this is 1, this is just going to be 1 plus tangent of u times 1 minus 1 times tangent of u, which is just tangent of u, and that equals my left-hand side. So I'm done. Okay? All right. We have, what, 2 more pages to go in 20 minutes? Yeah, we'll be okay. Oh boy. So here, what's on my last page? Oh yes, so very important things. Yeah, so some things more important than others. All right, so let's just dive into something that's pretty hard. So here's another verify formula, right? And so here I'm going to say I want you to show that this, or our little our difference of sums, right? A little finite difference formula. Let's show that that equals this. Well, okay, so how am I going to start with this? Well, I'm going to start with the left-hand side. I'm just going to start with the left-hand side. And my function of x is sine of x. So we'll just write that in. I'm going to have sine of x plus h minus sine of x all over h. And this is something you'll actually kind of do in calculus for 5 seconds. All right, so what I'm going to do from here, I'm going to use my addition formula. So I'll have sine of x cosine of h plus cosine of x sine of h minus sine of x all over h. All right, so what can I do here? Well, here, notice here I have, I'm going to move stuff around. I'm going to move stuff around because I can easily get you lost. I'm going to move sine of x here, cosine h minus sine of x. So I'm moving this forward, plus cosine of x sine of h. So what have I done? What have I done here? I've only just moved this one here and this one here. Then here I have a sine of x and sine of x. So I'm gonna take that out. I'm gonna have sine of x 1 minus cosine of h plus cosine of x sine of h all over h. Okay, so that's all I've done here. And so I'm going to leave this and I'm going to work on the right hand side for 2 seconds. And all I'm going to do here is distribute this h. That's all I'm doing. So here, if I distribute this h, I can rewrite this as sine of x cosine of h minus 1 all over h plus cosine of x sine of h all over h. And then I can rewrite that all as just 1 sine of x times cosine of h minus 1. Did I do something wrong? Hold on. Yes. Yes, is this what this was? No, that's not what that was. Get this. Why is my flow at garbage. Sorry, I made a mistake. If I factor out the sine of x, this will give me, oops, hold on, we'll go back to black. This gives me cosine, and this will give me a y. So cosine of h minus 1. There we go. So here, let's go back to here. So here I move the h and I multiply these two, so the h is just on the bottom. And since these are both have h on the bottom, we can just add them up. Plus cosine of x sine of h all over h. And does these two match now? Yeah, and so we're done. So here I give you a homework problem like this. And so let's figure out how the blankety blank we're going to do this mess, right? And this is what I mean about thinking mathematically. So here I'm going to say the sine. I want to express this in terms of x and y, okay? And only in terms of x and y. That means no sines, no cosines, just x and y. And here I have the sine of the inverse cotangent, or the inverse cosine of x plus the inverse sine of y. And I'm like, okay, so how am I going to do that? Well, let's just say this will give me some angle. I don't know what angle that is. We'll call it theta. This is going to give me some angle. I don't know what angle that is. It's going to give me some angle phi. And let's go to our right triangles. Let's actually draw a triangle for theta. And we're going to draw another triangle for phi. Okay. And let's put in what we know. So if the cosine, if this angle, what does it mean to be the inverse? The inverse says, it tells you what angle, what cosine of, let's see if I can write this right. When cosine theta equals inverse, oops, equals, theta equals the inverse cosine of x. Let me make sure I don't get you lost. So theta equals inverse cosine of x. That's what I'm saying. Let's just say whatever this is theta. That means cosine of theta equaled x, which is equal to the opposite over the hypotenuse, right? And here I can just, x is the same as x over 1. So here, not opposite, adjacent over hypotenuse. Sorry. Cosine is adjacent over hypotenuse. So here, I know what the adjacent is. The adjacent's x. I know what the hypotenuse is for this triangle. It is 1, right? Do I know what this side is? Yeah, this is a right triangle, so I can use a squared plus b squared. So this is just, so this squared plus this squared is equal to 1 squared, or 1 squared minus x squared, and I take the square root, is going to equal to this. And so that's 1 minus x squared. Does everyone see where I get this? If I had a right triangle, this is a right triangle. If I had 1 as the hypotenuse and x is this, that my other side becomes this. Everyone understand that? Yes, no, maybe? Kind of. Let's do it again. Let's do tangent. So tangent of theta equals to y. That means, or phi. Phi equals the inverse tangent of y. That means tangent of phi is equal to y, which is equal to opposite over adjacent, right? And so here the adjacent will be 1, or we'll just make it a 1. So here, y and 1. And so here, so tangent of phi is equal to y over 1. So that's the information. And here, this squared plus this squared equals this squared. So this will be the square root of 1 plus y squared. Not really. Okay, let's talk about triangles for 2 seconds. Let's talk about triangles. So let's pretend I have, so A, B, and C, right? So A squared plus B squared equals C squared, right? For my right triangle. So if I knew A and B, C is equal to the square root of A squared plus B squared, right? And if I knew A and C, I could say B squared is equal to I could say b squared is equal to c squared minus a squared, or which implies that b is equal to the positive, because it doesn't make sense to have negative lengths on a triangle, the square root of c squared minus a squared. So that's what I'm doing here. Here, I know this is y and this is 1, because theta of phi is the ratio of the opposite, or opposite over the adjacent, right? That's what tangent means, opposite over adjacent, right? For your right triangles. And so here, if I make that triangle, here I have y over 1. And so my other length of that triangle is 1 plus y squared, because of this. Because I know it, one side of the triangle is y, the other side of the triangle is 1, because if I'm building a triangle for phi, that's the goal. The goal is to figure out, if I build a triangle for phi, I can find out all the trig functions for phi. And I want to write this all in terms of y and 1, or x and y. And so that's what I'm doing. So I'm building these two functions here. Okay. And so I'm just using the Pythagorean theorem to figure out what the other side is. And so here I know, for this one, I know cosine of theta equals x over 1. So this is the triangle for theta, right? This is the triangle for theta. I know that tangent of phi is equal to y over 1. So this will be the triangle that comes from phi. Is it making a little bit more sense what's going on here? Not really, yes. Oh, yeah. Go work on the problem. You're going to see one homework problem on this. You may see one. You may see one of the quiz questions on this. It'll be really close to what you've done before, and we'll practice this more Thursday, and we may practice this more tomorrow. At this point, just because of how late it is, I may just finish this problem, and then we'll do page 4 of the notes tomorrow with page with 7.3. Okay. So that way I don't rush through this. I don't want to rush through this. All right, so let me get out my eraser here. I don't want to get out my eraser. I want to get out my thing because I was on the wrong layer again. Let's get out my little paintbrush. Let's make my brush super big. And then we're just going to paint in white because I have black, no white. And a soft brush. Oh, I'm doing a soft brush hardness. I thought about that. Oh, 100%. There we go. All right, so I'm going to need to get rid of this just so I have some room. I think this is essential, so let me leave that. All right, so now let's go back to this. All right, so why have I done all this mess? Why have I done all this mess? Because here I'm going to write this is theta and this is phi. So this, oops, I need to go back to black. So here I'll have, go back to black. Here I'll have sine of, here I have to call this theta, right, plus phi. Because here I said theta equals to this, right? And I say phi is equal to this, right? I've named it. I've done it any other letter, sure. Well, what's this? Well, this is the sine of, because I know how to do this, I just plug in my addition formula. This is sine of theta, cosine of phi, plus cosine theta, sine of phi. All right, so what's sine of theta? Well, here's theta, right? So theta is opposite over hypotenuse. And so the opposite here is the square root, or 1 minus x squared over 1, right? That's what sine of theta is. What's sine of phi? We look at this one, or cosine of phi. Cosine of phi is 1 over the square root of 1 plus y squared. So this is 1, the adjacent over the hypotenuse, which is square root of 1 plus y squared. I'm going to add that to cosine of theta. Well, cosine of theta, well, that's just x, right? And that's what it was here, right? Plus sine of phi, here we're going to go to here, sine of phi is y, opposite over the hypotenuse, so it'll be y over square root of 1 plus y. Now, it looks like a big, huge mess, right? And it kind of is. But that's okay. Here, do we have the same thing on the bottom? Yeah, it's 1 plus y squared. And so here, we'll just put it together. I'll have the square root of 1 times this is just going to be this. And so it'll be 1 minus x squared plus xy all over the square root of 1 plus y squared. And so I've achieved my goal. I've written all of this in terms of x and y. There's 7.2. All right, to finish up 7.2, this is probably the most useful thing I teach you that I know you'll probably use later is combining. So in differential equations, we do this a lot, where we take and you solve a system of differential equations and you want to write some a sine x plus b cosine x as a single sine or cosine wave. And so the way to do that is that you let k equal to the square root of a squared plus b squared. And phi satisfies the following, where cosine of phi is a over this and sine of phi is a over the, or b over this. Oops, it should be an equal sign in there. Sorry about that. So, and the reason that you have to do both is because he'll tell you what sign you are, okay? Because if they're both negative, you know it's in quadrant 3. If they're both positive, it's in quadrant 1. If one's positive, one's negative, it'll be in quadrant 2 or 4, okay? So that's why you have to know that's why you have to have both. So let's wander through how to do this. So let's just say we have 3 sine x plus 4 cosine plus 4 cosine x, and we want to write this in the form of k plus sine x plus y. And so I noticed we learned how to graph these, right? I guess we didn't do the phase change. The phase shift is just move it left to right by that much. It's not. So let's go ahead and crunch through this. And so the first thing we want to do is figure out what k is. Well, k is the square root of a squared plus b squared. So in this case, it's going to be 3 squared plus 4 squared. So here we'll have, and here we go, 3. So 3 squared is 9 plus 4 squared is 16. So square root of 9 plus 16 is 25. So this is equal to 5. So k is just 5. All right, now we want to have that cosine of phi equals, in this case, it'll be a 3 over 5, and then the sine of phi is equal to 4 over 5. So either way you do this, you can take, so since both of these are positive, we know it's in the first quadrant, and therefore the arc sine or the arc cosine will give us the right answer. So we'll just take the arc cosine just for kicks, 3/5. That's going to give us our phi. Crunch that through a calculator. We're going to get it to roughly equal to 53.1 degrees. And so if we write this all out, now we have our two parts. We have our k, we have our phi. And so we just write the answer here is 5 sine of x plus 53.1 degrees. And so here we've written this and this is much easier to understand what's going on. From here, could you tell what the max amplitude is? Well, not really, right? I didn't know what the max amplitude of that wave is. Here, we can easily say it's 5, right? And here, given any x, could you kind of figure out where you're at? Maybe, right? But here, given an x, you can just move it forward 53 degrees and then take the sine of it. And so it's easier to, so this is much more, A, it's more intuitive, and B, it's simpler, so this is a better way of writing this. And so this comes up a lot when you work with waveforms in engineering physics. Yeah, so okay, is the max amplitude. I see where I missed the little discussion. All right, why more importantly how? Well, that's a unique explanation. Anyways, yeah. And so it's a nice way of figuring out what's going on. So this is what we're going to do. We're going to do it one more time. I'll do it one more time with you, and then you'll do it on the, you'll do this on in the homework, and you'll definitely do this on the quiz. If for no other reason, it's really easy to write, because then I'll just say 5, say k equals what, round to the nearest decimal point, and your phi is equal to what, and then I'll tell you if I want it in radian degrees. I think I'll do this one in radians just to be different. Okay, and that way you've seen both. And I think I'll give it to you, ask you in radians. So here, let's have this one. Let's pretend I want to figure out what this is, right? I notice here that we have a 2x here and a 2x here. Well, it doesn't matter as long as I put a 2x here. Okay. So let's run through this. There is something I do want to warn you. That's why I made up this problem about this, but let's crunch through it. So let's first find k. K is equal to the square root of -1 squared plus the square root of 3 squared. So the -1 squared gives me 1, square root of 3 squared gives me 3, and that gives me the square root of 4, which of course is equal to 2. So here k is 2. All right, so let's figure out what is, so we'll have cosine of a, hold on, let me pull it up real quick. So let me zoom out just for 1 second. So the cosine phi is equal to a, in this case is -1, right, over 2. And then here we have cosine of, oh no, not cosine, sine of phi is equal to square root 3 over 2. And so here, we won't even actually need a calculator for this. What angle gives us a -1/2 and 3/2 for phi? And let's just do it, and in this case, let's do it in radians, just so you see both, right, in radians. So phi over here would be, if you have your little unit circle memorized, this will be 2 pi over 3. Okay? Which is right here. Because here I have a negative cosine of 1/2, and then here's pi over 3, 2 pi over 3, here's pi over 2. So that's how we get this. And so we can write this out as 2 sine of 2x plus, let me put parentheses around this, 2 pi over 3. If I wanted to figure out the period of this, remember, you do have to pull out the 2, and then it'll be x plus pi over 3. So the period here is only pi, because we're moving at twice the speed because of this 2, remember? And therefore the phase shift's only this much, technically, because of the way it crunches out. I'll